I want to talk some more about solving. So in chapter 4, we solved things that looked like this, right? Does this look like a familiar problem, like a chapter 4 problem? How do we do that? How do we solve something like that? Great. So we go to the unit circle, and what are we looking up on the unit circle?
Finding the quadrants with the things on the right.
The things on the right, okay.
Those
And what are we looking for on the unit circle, though, once we've figured out where to look?
Don't you go to the area where sine is, and then sine is, I don't explain it.
Which coordinate on the unit circle are we looking at?
Oh, I don't know.
For sine. Coordinate, not quadrant. Coordinate. Like, who said it? Say it loud if you know it.
Why?
There you go. And what value of y are we looking for? 1/2. So we look in quadrants, or between pi over 2 and 3 pi over 2 for where y is equal to 1/2, right? Pull out your unit circle. Find it for me. It's on the back of your identity sheet also. But take it out right now, or pull it up on your tablet, or whatever. Get it out. Follow it along. We're looking for where y is 1/2 between pi over 2 and 3 pi over 2.
5 pi over 6.
5 pi over 6 is the answer. Great. Everybody feel okay there? Okay. Now, in this chapter, we're going to change this problem just a little bit. So if I abridge this problem, we're going to consider the entire unit circle now rather than just 2 quadrants. What's that going to mean to us, though? Yeah, we can get more than one answer. So go look at your unit circle from 0 to 2 pi for the places where y is 1/2. So we're still going to have 5 pi over 6, but what's the other spot?
Pi over 6.
Pi over 6 is the other spot. So what we're going to see is that we're going to start getting multiple answers. Wrinkle number 1. But it's not too big of a deal, right? Now you can look at the whole unit circle instead of just like one little spot. In a way, it makes it easier because you don't have to figure out the right spot to look. You just look everywhere. The second wrinkle that we're going to have is that the problems aren't going to be pre-solved for you. So let's say we have cosine squared x is equal to 1. To be able to go to the unit circle, I have to have a single trig function by itself, right? So I got to get rid of that squared. How do I get rid of a squared? So we'll square root both sides. That sounds good. What do I have to remember when I square root both sides of an equation? Plus or minus, I heard somebody say. And what's the square root of 1? 1. So now our trig function is by itself. So we go to the unit circle. What coordinate are we looking for with cosine?
-1 and +1.
But what coordinate, though? X. There we go. So I can look for x equals 1 or x equals -1. All right, look at your unit circle. Pi over 2, x is 0. What else do you guys have?
Pi and 0.
So 0, and remember what the interval we're solving over. Oops, I forgot to write it again. We'll write it again. Notice 2 pi counts also. 2 pi is coterminal to which one of these two angles that we've written down already? 0, right? That's the same spot on the unit circle, so that one would count too. If this was just strictly less than 2 pi, then we wouldn't list 2 pi there. But I wrote it as included, so those are my answers. There, we got 3 that time. Whoa! What about this one? What should I do first? Oh. Nope. Yeah, let's divide by 3 first, right? Then you can square root both sides. That sounds like a plan. Now, how do you square root a fraction? It's an Algebra 2 topic. You all took that class last year. Just square root the top and then square root the bottom, right? What's the square root of 1? And the square root of 3 we can't do nothing with because that's that's a prime altogether. Well, if this is going to be a final answer, I would. But since it's not a final answer, it's just like something along the way, I wouldn't bother with it. Because what am I going to do with this now that I have the tangent by itself? I'm going to go to the unit circle. On the unit circle, what is tangent? Y over x. So it seems to me I'm looking at the spot where y could be plus or minus 1, and x could be plus or minus root 3, right? Do you see a spot on the unit circle that has those coordinates? No. So what are we going to have to do? We're going to have to do something over here. We're going to have to multiply this 1 over root 3 by something to make sure I get a coordinate on the unit circle. Not 2 pi. Look at the unit circle. Look for a coordinate that's similar to root 3 comma 1.
2.
I'm not going to multiply by 2, but you're close. How about 1/2? Oops. Why 1/2? Because if I look at the unit circle now, do you see a place where the x coordinate is root 3 and the y coordinate is 1/2? You ought to, right? That's on there. And because each of these could be plus or minus, there's going to be 4 possible answers, right? One where they're both positive, one where x is negative and y is positive, one where they're both negative, and then one where the x is positive and the y is negative. All right. Who can tell me the angle for the first one?
5/6.
Great. Second one? Great. The next one? Awesome. Next one? Great. So those are 4 answers. Everybody okay with how we got to there? Ooh, you can get 4 answers? Sure can. All right. What letter are we on here now? E, huh? What if we have a problem that looks like this? where I have more than one different kind of trig function. Ooh, scary. What do you suppose we should do first? So you might think to divide by tan, because it's like, oh, I'll cancel it from both sides. The problem is tan x is a variable, right? What value potentially could tan x take that would make division a problem? Not negative. Not a fraction. What? Not a square root. What number makes division a problem?
0.
0. Tan x could equal 0. So in dividing by tan x, we might be dividing by 0. That would cause us to lose potential solutions. In general, when you're solving, never do you want to divide by a variable or an expression involving a variable. Okay? So we don't want to divide by tan, although you're on the right track. What should I do instead? What's that? 2. The number 2.
Distribute.
I wouldn't divide by 2. I wouldn't square root.
Distribute it.
There's nothing to distribute because I just have like 3 like monomials multiplied together. Let me give you a hint. Last year in Algebra 2, you guys solved quadratic equations and polynomial equations. That should sound familiar, yes? What's the first thing you need to do in order to solve a quadratic or polynomial equation? The equation must be equal to 0. We're going to use the same procedure here. First thing I want to do is make this equal to 0. What do I need to do that? I'm going to subtract tan x from both sides. Now, is 2 tan x sine x and tan x, are those like terms where I can subtract them directly? Definitely not, right? So what does it look like when I subtract tan x from both sides? I'm going to just write it next to it with a minus sign, right? Now, back to Algebra 2. We're solving a quadratic or polynomial equation. After it's equal to 0, what do you do next in order to solve it? Probably no like terms to combine. Those are 2 different things. It's like xy minus x. Like they're just not like. So Jacob says you can use the quadratic formula. That's one way you do it. You could do it. But what if it was a polynomial where the quadratic formula wouldn't apply? What did you do then? Keeping in mind you could still do the same thing for a quadratic, not using the quadratic formula. Although that's a good answer, just not where I'm fishing at. So say like you have x squared plus 4x plus 4 equal to 0, and you want to solve that without using the quadratic formula. What else could you do? This should be the one skill you walk away from Algebra 2 with that you can do like stone cold. Factoring. Excellent. That's what we're going to do here. So 2 tan x sine x minus tan x doesn't look like a quadratic, right? So I'm not going to factor by looking for the 2 things that multiply to give me something and add to give me something, because I don't have anything squared. Mr. Whalen, how are you?
Doing well. How are you?
Good.
Okay, so this guy, anytime, even if it's at the end of the hour.
Sure, no problem.
Thank you.
You're welcome. So it's not like a quadratic factoring. It's going to be like a kind of factoring you saw in, like Algebra 1 or pre-algebra. Imagine you have a problem like x squared minus 2x equals 0. How would you factor x squared minus 2x? Well, not divide by x. Factor the x, because it's a greatest common factor. If I look here at the two terms, 2 tan x sine x is one term, minus tan x is the other term. What's the greatest common factor between those two? Tan x. Everybody see that? So if I factor that tan x out front, what does 2 tan x sine x change into? It turns into 2 sine x. Remember, when we're factoring, what operation are we doing, really? Dividing, right? What does tan x turn into? 1 is correct. Tan x divided by tan x is 1. So now I have this factored. Let's go back to Algebra 2. You've had your quadratic, set equal to 0. You factored, and then you set each factor equal to 0 and solve. That's called the zero product property. That only works if they're equal to 0, because you know if you multiply two numbers together and get 0, the only way that can happen is as at least one of those two numbers is 0. So we apply the zero product property. We have tan x equals 0. And then 2 sine x minus 1 equal to 0. Everybody still on board? Is this looking familiar, like a polynomial solving problem from Algebra 2? That's the goal, is try to connect it to something a procedure we already feel relatively comfortable with, and just like fold our new stuff on top of that. Okay, tan x equals 0. I'm ready to go to the unit circle there because it's just a single trig function, right? So I go to my unit circle. Tangent is y over x, and that has to equal 0. Okay, so what does y have to be? 0. What does x have to be? Anything that's not 0, right? Okay, so go to your unit circle. Where are the places where y is 0 and x is not 0? So pi, 0, and did we say this was, we didn't give an interval. Let's pretend it goes to 2 pi also. Right? I'll go and add that in here. I keep forgetting to do that, guys. There we go. Okay. So far, so good? All right. How about 2 sine x minus 1 equals 0? I'm going to add 1 and then divide by 2. I'm going to do that all in one step. Everybody's okay with that? Now we're back to the unit circle. Our good old friend sine x equals 1. We've done that like 3 times now. Sine is y. So where on the unit circle is y equal to 1/2? And then also at 5 pi over 6. So here we got 5 answers. And we can just kind of keep leveling the solving complexity up. But this is the gist of what we're doing in 5.2. So that's okay. Should feel relatively familiar, right? It's mostly just a chapter 4 skill. We're just looking in more places and then making you do some extra solving at the front end. and looking more places at the back end, but like the middle is still the same skill where we're going to the unit circle. So for today, you can be working on one of three things. So I have a delta math for you. Let me show you what's on there. So there's three types of problems on there. One type of problem is just like what we've been doing. So if I wanted to solve this, I'd add 1 to both sides, square root both sides, go to my unit circle and look for x equals 1 or x equals -1. So that's going to happen at 0, and that's going to happen at, I guess we should say, and then at pi. And notice here, this is x is strictly less than 2 pi, so we are not going to count 2 pi this time like we did in the example before. So I'm just going to type in my answers now. So I'm going to do 0, and I'll do comma to get a spot for a second answer. Pi, submit, done, right? So it's just like what we've been doing here, examples. So far, so good? Okay. Your next one, the directions are going to ask you to simplify the trig function with or simplify to a single trig function with no denominator. So this is just like what we did in 5.1. So again, we're going to be using algebra and identities to do this simplification. If I look at this, is there any algebra to do? No, it's a single fraction. There's no reducing that can happen here. There's no algebra. So what should I do then? I pull up my identity sheet and look at my identities. So what I'm going to be looking for is either something to change sine into a cosecant or something to change cosecant into a sine. R4 or R1, right? Those are the two choices. So what I'm going to do to help me think about this is I'm going to think about this fraction, sine over cosecant, as just 1 over sine times 1 over cosecant. So I have my choice now. I can take 1 over sine and turn that into 1 over cosecant, or I can take 1 over cosecant and turn that into sine. Everybody agree? If the directions say they want no denominator, I want to change 1 over cosecant into sine. Is everybody okay with my reasoning there? So I think that's R4. So that's going to give me sine theta times sine theta, which is just sine squared theta. Everybody's good with how I got to there? So I just did the shift 6 to make an exponent, like the same caret key that you would use on your calculator, and I typed the 2 and then pressed over to bring my cursor back down to the main line and use the theta button there. I gotta do 10 of these, but they're all gonna be relatively similar to this one, where you might use 1 or 2 identities and should be pretty straightforward. So far, so good? And then your last problem is just about remembering which things are reciprocals. So the reciprocal of secant is? It's cosine. And it just, if you're confused, use your reciprocal identities from your sheet. Just about practicing that and getting more familiar. Those should be like 10-second problems at most, those last set. So that's one thing you could be working on. Second thing you could work on is the 47 through 62 that we started last class. The third thing you could work on is your exam review. Any questions? I'm going to stop talking now and let you guys be productive. Okay?